In the previous film, I showed some of the basics of the SFC programming language. In this film, I will show how to build an SFC program in Codesys and focusing on the alternative and parallel branches. There will be another example in Codesys in the next film where I investigate the qualifiers and show how we can make transitions and actions as subprograms. In the previous film, I used this example, and I will make the same code in Codesys where we have this alternative branch. I have started Codesys, and I will make a new project. Give it a name, SFC example, and make sure that I make it a standard project. Now I get the question on which device to use. I will continue to use the ControlWin V3 since I'm still not connected to a physical PLC on my computer, but I will change programming language to SFC. Yeah. Here is my SFC program. You can see that it's SFC on the symbol here. Double click it and it is here. As in my other programs, I should probably use a global variable list for my physical input and output signals, but just for testing, I will use them in the local variable list. The SFC program that I'm starting with, it's doing absolutely nothing. It starts in init, then it has a transition that is always true, which takes the program back to init again. In our example, we started by checking button 1. I will do that here by typing button 1 here. Button 1 is not declared, therefore I get the auto declare, and I will choose to have the variable declared in the local variable list. Okay, there it is. If button 1 was pressed, the process should move forward. For that I need a step and a new transition. I can find step transition here. I can also find step here, and then I have to add a new transition myself. Therefore I prefer to use this one because then I will get both of them here. We must always have step, transition, never two steps together and never two transitions in a row. Here is my forward step. If I want to, I can rename it from step 0 to forward by just clicking and writing. All steps must have a name, a unique name, because the program needs to store in the memory in which step it's working. The program should remain in the forward step until the front sensor was activated. Here we have the front sensor. I will declare it, and now the program will go from init, wait for button 1, into forward, wait for sensor front, and then back to init again. We can try that. I will go to online simulation and log in, and I start my program. Here the program is in the init step, waiting for button 1. I activate button 1. Then the program is here. In the forward step, I can deactivate button 1, and the program will remain in the forward step until sensor front is active. And then the program goes back to here. I can deactivate sensor front again. I log out to complete my program. In the forward step, we wanted to have an action, something that the program should do while in this step. To add an action, I right-click on my step, and we can see here that I have the possibility to insert step transition from here as well. But now I will have an action association. By default, I get the N. The N qualifier means that the action will be active while the step is active. And here I want to move the motor forward. That is a new variable, boom. Now I want to have this alternative branch, where I want to do more or less the same thing, but for button 2. I start by choosing where to put my alternative branch, by marking the transition, and then again, using control, the transition where it should end. And then I can use the button up here, insert branch right. Now the branch started immediately over the first transition I chose, and it ends immediately under this transition. And here I will add my button 2, my back sensor. If I want to, I can rename the step back, and I will add the action association for driving the motor back. Now I have the program as in the example. I will log in to try it. I can log in with download to ensure that I will start in the init step. And I start. As before, the program is waiting in the init step for something to happen. We start by trying button 1 again. Activate it by preparing the value true and hit Ctrl F7. Now we're in the step forward and mode to forward is true. Deactivate the button. We're still in the step. I can try activating button 2. Nothing happens. You can see that the button is activated, it's true here, but the program will remain here, waiting for the front sensor to become true. I release the button 2 and activate the sensor front. Now, mode to forward is false. It was only true while the program was in the step where it was activated because of the qualifier N, and the program is back in init. Deactivate the sensor. If button 1 is false and button 2 is true, then the program should go this way. I activate button 2 and we are in the back step. I can deactivate button 2. I can try to activate button 1 and the program is still in this step, waiting for sensor back to be true. Deactivate button 1 and activate sensor back. And the program is back here. Deactivate the sensor again. Now I will try what will happen if button 1 and button 2 becomes true at the same time. I can do that by preparing true for both buttons, and then I write the values at the same time with Ctrl F7. Both transitions here are true, but the program is choosing to go here because it always checks the left transition first and then the right one. I will add another step in this branch. Now, after hitting the back sensor, before going back to the idle state, the program should push a cylinder. I add a new action association, pushing the cylinder, and the cylinder will be active for 10 seconds. And then deactivated, and the program will go back to init. When the program is running, there is always a clock running in the active step. I can use that clock by using the name of the step. Here I haven't changed the name of the step, I could do that, but I will use that name, step 0. And then .t, that gives me the clock in the step. I will remain in this step for 10 seconds, and I write greater than, or maybe greater than or equal, t hashtag 10s, 10 seconds. You can try that out as well. Log in with online change. You can see that I'm still in this forward step, waiting for sensor front to be active. I can release button 1 and sensor back and activate sensor front. Now the program really quickly went to init and then directly to back because button 2 was already pressed. You can see the clock running here. Motor back is true. I can release button 2 for the program to not go directly down here again next time, and activate sensor back. Now this clock is running. The cylinder is true. Motor back is false. And now we have the 10 seconds and the program is going back to init. Now I want to make a new step here. I can drag my step from here if I want to. Yeah. But then I have to remember to bring a transition as well. And Codesys is reminding me of that by making init red. And if we hover, we see step, jumps, and parallel branches have to be preceded by transitions. I will add a transition as well. Yeah. In this step, we will wait for button 1 and sensor front. And I can write that directly in the transition here. I can use and, or, not, brackets, greater than, less than, as I did here. And I add a new step transition behind it. Here, I would like to have a parallel branch. You can see that the alternative branch, it has the branch first and then the transition. and it ends with separate transitions for the two separate branches. However, the parallel branch needs to have the same transition for both branches, both for going in and for going out. Therefore, I will mark my step to make the branch. In the parallel branch, we have two parallel lines here, and the program will go into both steps at the same time when this transition is true, and then it will remain in both branches until this transition is true. You can use sensor back for that. If I want to, I can have more steps in one of the branches or both. I make a new step here, waiting for button 2. I will try this program. My program is still in the init step, waiting for button 1 or button 2. We'll go for button 2. The sensor back was active, which means that the program immediately jumped to step 0, waiting for the 10 seconds. And now we're in step 1, waiting for button 1 and sensor front. Sensor front is true. We can make button 1 true as well. I will release button 2 because I will need that here, and also sensor back to see what will happen. I will make them false first, and then I will make button 1 true. Now the program is in both steps here. I can make this condition false again, and the program remains in both steps, waiting for sensor back and for button 2. I will show what will happen if I activate sensor back first. Nothing. The program is still here, waiting for both branches to be waiting for sensor back, which means that we can't jump from here to here. Need to go through step 4 as well. I will make sensor back false again and make button 2 true. Now this branch has moved to step 4, and now if sensor back becomes true, both branches will be ended and we'll go back to init. I'll release button 2 and make sensor back true. And now we're back in init. In the parallel branch, we used both branches at the same time, and they are waiting for the same transition to be true, but they have to be in the last step in both branches. In the alternative branch, we can make the decision to go either there or there, and then they end up in the common flow again when the branches go back together. We have used the qualifier n to make an action active in the step. We have used booleans for the transitions and expressions with more booleans and also a time in the transitions. And we have used the action to make a bool signal become true in the step. In the next film, I will show more ways to make actions and transitions, and I will investigate more of the qualifiers for actions.